So question 1 states, the following graph shows the function with the rule gx equals to, and they give you a generalized form. So this graph down here, it's a hyperbola. And so we have Q, which is located at -3 and 3. So that's that point there. We know the exact coordinate of it. So what we're going to do is you need to obtain the rules for your asymptotes. So you can see that this vertical line here, this is an x asymptote. So that means that x is equal to -4. That's the equation of the asymptote. And up there, we've got y is equal to 5. Okay? Now, what we're going to do with these two values is we're going to place them back into our formula, because the question in question 1 states to find the formula of gx. So gx, so far using that information, is a divided by. Now what we're going to do to obtain the denominator of this hyperbola is we're going to turn the solution of x equals to 4 into x plus 4. So we're transposing the number and putting it on the other side of the equal sign. And then we're taking, to find d, we're just using plus 5. Okay, so that's all we can fill out right now. The next thing that we should do is, we know that Q is at -3 and 3. And so we're going to be using this particular coordinate to identify what A is. So this is our x value, this is our y value, or in other words, our gx value. So we're going to substitute the coordinates into the equation. So we've got 3 equals to A divided by, we have -3 for x, plus 4, plus 5. So our aim is to find the value of A. So we've got 3 equals to A over, the denominator is 1 plus 5. So A is actually -2. When we take this 5 over to the other side, it becomes -2. So therefore, our equation gx is equal to -2 over x plus 4 plus 5. And you can put that -2 at the top there, or you can put it on the side here. So that's our formula of gx. Okay. So the next question, question 2, we have to show that g1 equals to 5 is not a valid statement. So if we just look at the graph, we can see that it's actually not going to be possible when you substitute 1 in. Let's find 1 on the graph. Okay, so here's 1. You can see that you're not going to get 5. You can't get 5 because 5 is on the actual asymptote, and therefore it's not going to be possible to find a value. You're not going to reach your asymptote, but we have to show this mathematically. So we need to, hang on, we need to substitute 1 in. 1 plus 4 plus 5, -1 all over 5 plus 5, which is equal to 5 take away 2 over 5, which is equal to 25 over 5 minus 2 over 5, which is 23 over 5. So that's the value of g of 1. So since, I guess you would have to say, since g of 1 is equal to 23 over 5, g of 1 is not equal to 5, because this fraction here, it's not quite 5 yet. So that's a conclusion that you need to draw from the data. Okay, so the final question, question 3, find the solutions of gx equals to x. Okay, so what we're doing in this scenario is we're introducing a new value. In this case, it's just the line x. So if I just draw a line x here, and I draw the other side of the line x, I can see that there are two locations at which the line and the hyperbola are equal to one another. So those two locations there. So to complete question 3, it's important to equate the you're making gx equal to the value of x. So and therefore you need to solve for x. So this is equal to x, like so. And then we just need to, I guess what we can do is we can move this 5 over to the other side. And then we can multiply both sides of this equation by x plus 5. So when we do that, we get minus 2 equals to x minus 5 times by x plus 5. And then we simply need to expand that. So you get something like this. What we can do now is we can move the 25 over to the other side. That will give you 23. And therefore x equals to plus minus square root of 23. So these are our two x values. And then to find the equivalent y value, it's easiest to substitute sub x into y equals to x. So therefore, so the coordinates of where the line and the hyperbola cross, there are two coordinates. So one of them is square root of 23, and then the equivalent y value is also square root of 23. So these are the intersections. And then we've also got minus 23 and minus 23, square root of 23. Okay, so that concludes this question.